All right, hello everyone, and welcome to a new Dr. Spotfire session. The today session is Unleash the Power of Spotfire with Analytics for Energy Suite, or A4E. I'm joined today by Blue River Analytics, Steve Hoy and John Guthrie. Welcome aboard. So I'm going to give a little bit of housekeeping, and then we will switch to you. What is Spotfire? So we talked about this in other sessions. Spotfire basically is a visual data science platform that helps people to couple their innovations and the tool itself to solve daily challenges. Our Dr. Spotfire sessions are every first Tuesday of every month, 11 a.m. CST. And if you missed that, you can always watch the previous sessions on our Dr. Spotfire page. How the Dr. Spotfire sessions work. So basically, we have monthly sessions, and then we have quick tips. And all these ideas and suggestions are coming from a couple of channels. So you can submit your ideas to our ideas portal. You can always create a post on our Spotfire community. You can reach out to us, either me, Jose, or Boris on LinkedIn. You can always leave comments on Twitter, email, or on YouTube. And then all of these, let's say, comments and ideas, they will translate either to Dr. Spotfire sessions or to tip videos. And then they can be in a form of data functions, Spotfire apps, accelerator. And then our motto is the learning is not driven by answers, but by questions. This is our confidentiality and disclaimer. And then now over to the Blue River Analytics team to talk about the analytics for energy. Steve and Guthrie, over to you.
Okay, good morning, everyone. My name is John Guthrie. I've been working in oil and gas since 1981, and I've been working with Spotfire since about 2010. So, and other business analytics tools before that. So we've been, Steve and I have been working with Blue River Analytics now for 10 years. It's been on the go for 10 years, and we have three sort of streams that we work with. One is templates and building Spotfire tools for our customer base, of which there's over 200 customers now that we support with Spotfire templates and tools. We have on-demand training, so probably the only on-demand training for oil and gas. So all of our training is based on oil and gas data and wellheader production type data. And the third part is that we do consulting as well. So we do Spotfire consulting on a T&M basis, or we do something similar to what you're describing. We do office hours. So I do coaching and mentoring on a sort of hourly basis, book some time, and help our customers maybe get over a hump with a particular Spotfire problem, or do some coaching as to how they might tackle the problem. And the same goes for Steve. Steve, do you want to introduce yourself?
Yeah, it's pleased to see everybody there. My name is Steve Hoy. I think I've got John Guthrie by 1 year in the industry there. John, I started in 1980. So worn a number of hats with major and minor companies and consulting, and at this point specialize more in the custom software development, particularly around Spotfire. And it's been a pleasure working with John for 10 years here now.
Okay, so what we'd like to do today is take you through this analytics for energy workflow. It's a forecasting and valuations workflow. And I'm going to start off by just walking through all the pages that are in it. And then we're going to focus in particular today on the DCA and using MCMC type machine learning for building curves, in fact. So anything you'd like to add to that for the moment, Steve?
No, I think that's great. I think we said this off camera. We should say it on camera. Hopefully, we'll have a little fun here with this. You'll find it very interesting, hopefully, and hopefully there'll be some questions along the way there. If you do, Chair will take care of us here, and we can handle those as he will. So we'll look forward to that if you get a chance.
Okay, so you can see my Spotfire screen here. I'll just make a few comments. All of our templates are pure Spotfire. That means there's no robots, no trips to the cloud. It's all Spotfire, Python, or R, or IronPython for the scripting. And I try and do is build workflows. So in this particular template at the moment, this demo template, we've got 26,000 and a bit wells, 26,455 wells. And I've got 3 areas in it. These wells are all in the Permian, by the way. So I've got wells in here for Andrews and Glasscock. Andrews we actually use for our on-demand training. So that's a well set that we use within that. And Glasscock is an area that Steve's very familiar with, and he does most of his testing of the tools and so on for the wells in that area. So he spent quite a bit of time, I think, eating burgers or somewhere around around there. So I'm going to look at this middle area. We've got in Midland, around Midland, I've got a bunch of data that has directionals in it. So basically, we've got just over 2,752 wells with directional data on them. So I'll walk you through the process. The first part is that we just mark some wells. So we find the wells that we want by using the tree map and navigating with that or filtering with that and so on. Then we mark the wells. The next stage in the process, because it goes left to right along here, is we review the production. So we've got various ways of looking at the production. We've got cube charts, a log style plot. I can change the date on these charts, so it's a time zero type plot. Up here is an area chart mod that we're using in this, but we can change it to be look at it by operator or group it by operator if we want. And you see the colors basically change along those lines. And on the right-hand side is oil, gas, and water per day, or we can look at it from a volume perspective. So while we're reviewing the data, then we can obviously use the Spotfire marking and filtering to hone in on any particular wells. This graphical chart here is ordered by production months. So for my purpose, then I'm going to take just select all the wells here that have got more than a year's worth of production. And our template actually handles, there's a setting that allows it to take either daily or monthly data. In this case, it's monthly production data that we have. So we've selected our wells that have got more than 12 months, and we can then start to sort of look in the back of what does that mean for us. So in this case, we could pick up some wells on the map here. And when we select them here, this set here from the map, this is the well spacing gun barrel mod. So I make use of the mods whenever I possibly can. And we do have 3D well spacing, which could be a topic of a whole separate Dr. Spotfire, because there's a lot of maths went into working out the ellipticals and so on around these wells. But basically, we can pick a couple of wells that are close together, for example, here, and we can see the curves for them, right? And Steve will explain the nature of what's going on the ratio side later on. But basically, we can look at the well spacing before we run the DCA or after. If we've run the DCA, we'll actually see the curves that are involved for the wells to see if there's any communication between the wells. Then we have a statistics page. Okay, so again, for the wells in this production set, then I can set any attributes that I want. So we actually calculate, when we load the production data, we calculate production metrics for 3, 6, 9, 12, and so on, and also WOR and GOR as we go. So you can take any of these metrics from the well header, attributes from the well header, and then basically we could color it by vintage if we wanted to, and so on. So it gives us a method of doing a comparison between the wells, using all the good stuff that Spotfire allows us to do with the marking and filtering, and see how the stats play out in terms of P10, P90s, and means and medians and so on the attribute data that we select here. And then finally, we use we try and group wells together by their numerical attributes. So I use k-means for that. And the way that this is set up is that you can configure up to 8 numeric columns. Okay. Configure it, and we can change them to rerun the k-means. But we could change them and then refresh the k-means here. But basically, I've got it set that it goes to 5 clusters. It could be more, could be less, but 5 seems to work pretty good for our purpose in terms of seeing where the clusters relate to one another in terms of the attributes, the numeric attributes.
And can you adjust the number of the clusters here?
I can change the
parameters.
This is on the set of wells that we've selected. So this is on the well set that it's trying to group them together. Okay, so the next page after this is the DCA and MCMC calculation. Steve is going to talk through these, so I'll move on. We have in this workflow, then we've got normalization. So the normalization starts with a multivariate analysis against all the numeric attributes that are contained on the well header, plus the ones that we've calculated in terms of the production metrics. And then we can select a number of these, one or more of these, based on their correlation to the result variable that we're looking for. In this case, our default is EUR, but it could in fact be any value that's sitting on the well header that we could solve for. So we do a multivariate to start, then we select the higher values for the correlation, and then when we click it again, it does a principal component analysis. In this case, the 2 principal components, which then normalizes the production data. So we can choose during the DCA, and Steve will show that, whether we want to apply normalization or not when we're generating type curves. Okay, MCMC is the next page on this. And again, this is a way of looking at the distributions of the EURs themselves. Okay, and just looking at one well in terms of oil here. And again, this is an integral part of how the curves are calculated. And Steve will actually be explaining in more detail what's happening here. But basically, we're generating, using machine learning, distributions of the parameters of EUR, the IP, the B factor, and the effective declines. So we're using the machine learning to come up with an optimal set of parameters for the curves. And the final part of the workflow here is economics. So for every well in the well set, we can actually input timing variables such as start months drilling, completions, production, tangible, intangible costs, expenses and taxes, gas and production metrics, and commercial terms. And we have four different contract types for gas pricing. And then there's a price deck at the bottom here, which we can, it could be a spreadsheet loaded into the template, or we could lift it from the internet if need be. But we do multiple cases, so we can look at the different cases here. And again, we use the washing line style chart to actually show the income and then backing out all of the expenses to give us a value. And the trellis on this one is allows us to, we put the trellis off, it does a roll up for the whole well set based on this particular case, or this one for that matter, or we can compare them together. On the bottom here, I'll point out we do have imports and exports, And we can export our data out to Aries and also to PhD Win. So the last piece I'd like to mention is we actually map. So our templates typically use well header and production data. In this case, we've got directional surveys. So how we get away without having to change the visualizations is we map the data into the templates. So these are all the columns that I need to not break the visualizations in the template, is how I would describe it. So we map the columns here. You know, I can pick the column for API, then I would expect it to map to the production data and so on. So I don't really care what the column names are in the source data, the well header and production data. I just end up mapping them into the template itself. And that's what these V columns are for. So I can actually, all of our mapped columns start with a small v. And so I can filter them in, filter them out, and whatever from the visualizations as well, if I wish to. So with that, I will hand over to my colleague, Steve, to walk us through the DCA and the MCMC. Over to you, Steve.
Very good. Thank you. Can you guys see my screen okay?
Yes, now you're showing the decline curve analysis, right?
Correct. Yep.
Yep.
Looking at decline curves.
Yep.
Good. So I'll dive right in. I think John mentioned Glasscock County in the Midland Basin down near Midland. I'll put in a little plug for Nelda's Cafe. They have the best burgers, I think, out there just east of Garden City that I've ever had. And when you've been sitting in the field for a few days, it was a wonderful thing. So there it is. There are a couple items I'd like to cover here. John mentioned the overview of the template, but what I'd like to talk about are the decline curve modeling that we do in the template. And there are a number of aspects of it that I'd like to cover. And we'll do an overview coverage of it here. Certainly, if there are questions, we can answer those. But the first thing to kind of point out is this rather busy chart that you see down here at the bottom. Yeah. Imagine what I've done here is actually taken a well set and done a decline curve analysis. I do that by opening up the Autocast model controls and just clicking on the icon here. You can see there's a number of parameters to set here, and we'll touch on some of these in the course of the next few minutes. If I grab one of these wells, I can grab and start to look at individual wells here, and how the fit looks and so on and so forth. But one of the things I'll point out is the chart below here. This is called a ratio chart, and it's basically the result of a sliding window that we use to analyze changes in the production curve. And specifically what we're looking for are things like this, where you get a drop. Maybe that's a frac hit, or there was some sort of a fracture that we got into and there's water. Who knows, right? But at the end of the day, this algorithm, it's a sliding window algorithm. And you can see on the green, which is the oil curve here, that it's showing a sharp down peak. And that is, it's detecting an event that's a down event in production. If you've noticed, the decline curve, the auto casting that was done, was actually forced its way right through this. And you can see to the detriment. It's certainly too high in this area. And more importantly, the EUR here is going to be too pessimistic because of the sharp decline that it ended up having to do, because it's fitting this segment and this segment together. So using the start-stop chart, we can actually see here this down event. We can adjust the threshold here. And if I do that, I can come over here, see the segment threshold low for oil. If I put that at -1, you'll see here that this green line will move up, and you'll see now this is actually below the threshold. I can come over here and say, let's append a new autocast of this well to the well set. And I simply click on the button, and this will be re-autocast with a new lower threshold here, okay? Now, I've already done that. And if you look, you can now see that if you change that threshold here, that's forced, the start-stop algorithm has forced this fitting to actually acknowledge that this is a different segment. And if you look carefully, you can see a very accurate decline curve fit that's associated with this latter stage of production. We maintain then that this algorithm would give us a better, actually a more optimistic look at what the forecast might be for production in this well. So that's the power of this algorithm. It's kind of fun to look and see overall when you look at, if I select all the wells in the well set, you can kind of get a sense of the scatter. And the first thing you notice is that the gas is much more volatile than the oil. And that's one of the reasons why we can change the thresholds for this start-stop algorithm, right, to start new segments. We can make them different for gas than we do for oil. And you can see that the red stippled lines that represent the upper and lower thresholds here are certainly wider than than at least the lower threshold on the gas side. So when you're looking at this, that's what this chart is for. As John mentioned, it does come into play a little bit when you look at well spacing. And we can actually look, and this can actually detect frac hits. And with the gun barrel plot and the 3D calculations that are made about frac ellipses, we can actually then try to corroborate the frac hit that's noticed on the production with some of the analysis that's done in 3 dimensions with the well spacing tool. So that's another great use of this particular piece. So move on from there. What I'd like to do is talk about Markov chain Monte Carlo and why we think it's an important and useful approach to decline curve fitting. If you look at this this Autocast result for this well, and I'll step my way through. We can look at all kinds of different outcomes here, different wells. You can see that the decline curve fitting, that the data is noisy, certainly, right? In fact, I think that first Bearcat well we had the noisiest data. And the problem with, I think, typical decline curve fitting is a deterministic estimate of what the decline curve here is going to be wrong, right? We know it's wrong. There are a lot of different ways to draw this curve. And the one that we get here, if it's a least squares or whatever's being used, it's going to be wrong. The question that we try to answer is, what are the error bars around the decline curve that you see here, based on the fact that we're dealing with noisy production layers? That's the question, and it becomes important not only from a cumulative production standpoint, but also from an economic standpoint, what EURs look like, what cash flows could look like, and what are the upper and lower bounds associated with those. So I take this well. Let's go ahead, and I'm gonna move on over to one of the screens that John touched on real briefly. That what we can do is talk a little bit, and I'm gonna work my way over here to another screen, and we're gonna talk about what's going on with the machine learning part of this algorithm here. So let me maximize the particular chart you see. What Markov chain Monte Carlo is doing is it's iterating. You might get that from the Monte Carlo part of the Markov chain Monte Carlo moniker, right? But in this particular case, we've told the algorithm that we want to run 2,000 trials for every well. And it starts at a starting point. You're looking at the 4 different ARPS parameters here, right? The one on the top, I'll use this for now, is the IP, Q initial, QI. You'll notice that the starting point was around 30 barrels per day. And what the algorithm did is, as it started, it randomly perturbs each of the parameters in ARP space. It then measures from a Bayesian standpoint what the likelihood is that the perturbed model is better than the one it previously. And to the extent it's better, it will start to learn which direction to move these parameters in unison in a way that that converges, that gives us the best explanation we can get for the model based on the noise that's associated with the production records. So you can see here, this IP very systematically rises until it gets up around 100 barrels, maybe a little less. And then it kind of levels out, doesn't it? You see it kind of in a natural up and down. And so we call this initial stage of Markov chain Monte Carlo the burn-in. And you can set how long the burn-in is. But in essence, what you want to do is you want to use as a final model only the points and only the decline curves that result from this stable up and down, right? This would give us some feel for the natural variation or the uncertainty in this IP, right? After the algorithm has converged. We don't want to use this because the algorithm has not converged. It's still burning in. Notice the similar patterns when you look at these other curves. This is the initial decline, the hyperbolic effective decline rate. This is the B parameter you see right here. You can see that it's stabilized at a high value around 2.8. And you can also see this is the time to exponential decline. And that one has also converged nicely. So from a standpoint of parameterizing or setting the parameters on the Markov chain Monte Carlo, this would give you some intelligent estimate. If we have it somewhere over 400 samples, we, at least for this well, we're going to be nicely converged, and the uncertainty we see is going to be a realistic measure of the uncertainty that's associated with our decline curve. Okay, so the most important thing about this is to know that machine learning is going to get us into the right area where these parameters converge, and then once they've converged, we can actually look at the variation in these different ARPS parameters, and in fact measure the variation in things that are determined by those parameters, like the EUR. Okay, so I'll go back for this particular well, and we've got a series of different diagnostic plots that we can use to kind of look and see about the convergence. But you can also look here, like at this scatter plot, and you can see that in this particular case, you can configure this. We're plotting QI versus the effective decline rate here. And you can see a very clear pattern between these two things here. So at the end of the day, this becomes helpful for us to kind of get some feel. It's saying here that the natural variation due to the noise in the data for the effective decline is going to be somewhere from 86% down to somewhere below 78%. And that since this model's converged, all of these values represent some realistic natural variation that's possible, that still effectively explains the data that we're looking at as we see it here. So I'll go back to this main screen here, and we can kind of take a look and see some of the interesting consequences of this work here. First of all, if you look at this histogram, you can see this is the histogram of this converged decline curve. And you're looking at the stochastic, the uncertainty in the form of a bar chart here for each of the ARPS parameters. In addition, by clicking down on this EUR button, the MCMC EUR, we'll take each of the converged decline curves that we get from this process, from this Markov chain Monte Carlo process, and we'll calculate the EURs so that we can get a bar chart showing the uncertainty around these parameters here. Now, just to kind of give you some feel of why we think that this particular stochastic approach and the Markov chain Monte Carlo specifically is important, is that you can start to see the variation in the EURs here. And some of these wells have a very large, indeed, variation in what the possible EURs are. And to look at that, we can start to get a sense. So I'll show you this well here. This is a variation that goes somewhere, most likely EUR is going to be in the 165,000 barrel neighborhood. But notice here it can be anywhere from 155,000 all the way to 190,000 barrels, right? If that's let's say a 30,000 barrel increment, it's a little more than that. That 30,000 barrels at $100 a barrel is obviously $3 million. So if you look at the net present value NP0, PD0 of the cash that you're talking about here, you're looking at numbers even at $80 a barrel that are in the millions of dollars in terms of uncertainty. So we kind of leave that with you to kind of emphasize that we believe that stochastic techniques are important in decline curve fitting. We'd also say that Spotfire provides the ideal vehicle for us, for engineers to be able to gain insight into what this uncertainty means, and then to start to be able to quantify that uncertainty and translate it into good decision making when they get down into a drilling program or completion optimization or whatever it is they really need to look at. So I think we're at the bottom of the hour. This is a place that probably be a good holding up point here. I think I can turn back to a chair here to our host and ask him if he has any questions or any comments for us here.
Yeah, this was great, Steve. I like the way that the application is designed. I guess the logical steps that takes you from the exploration to all the way to the economics. I do have a couple of questions though. First question is, where is this data coming from? I mean, where is it stored? Let's say in a database? Is it like in static files? Like, how do you access the data?
Okay,
Yes.
so we
Go
can
ahead, John.
import the data from multiple sources. So within our customer base, we've got customers who pull it in from IHS or Enverus DI, TGS, Well Database, and their own Conduit and their own proprietary data gets loaded into this. So that's hence the mapping screen that I showed you. So you can have several different copies of this template connected to different data sources, or we can do comparisons between the data sources by just using the Spotfire ETL to merge the data together. So we can, to the wellheader data from these external data sources, quite often we'll add proprietary data in terms of proppant per foot type numbers or whatever, which sort of expands the possibilities for the engineer as to how he wants to sort and filter and look at the data there. So that's where the data comes from. So we're data agnostic from that perspective. So if the customer, we've imported from Aries into here, and PhD Win for that matter. So and we've taken data from Combo Curve as well and plugged it into this approach. So we have we can export out in those directions because of the nature of the stochastic DCA curve fitting that we're doing. We've got a tendency to do much more tight fitting than is done with these other tools. And the other interesting thing is that with this version, we're getting we can do 5 wells per second, both streams, plus the Markov chain Monte Carlo, and that's inside Spotfire. So that's you could test it out, but I did those 2,700 wells in just 2 or 3 minutes.
Oh, wow. That's impressive.
So the performance is down to some of the techniques that were being used and how we actually use Spotfire, and some caching techniques that are used and how we pass the document properties into the data functions. But overall, the performance is I'm saying I'm delighted with it because it's
Great.
as fast as what we had in the previous version, but it's actually doing the Markov chain Monte Carlo as well.
Okay, so is your that's maybe a question for you, Steve. Is your Autocast model built on the top of the Markov chain Monte Carlo? Or like, I'm trying to understand, like, how does the Autocast benefit from what you're doing? Because I think what you've done with the Markov chain is impressive, but how do you like employ that within your auto forecast model?
So what's happening, Jer, what's happening in the background is you basically ask yourself a question from a Bayesian standpoint, and that question has to do with the data, with the production records. And the question is, what's the likelihood that, let's say I just draw a random curve up there, what's the likelihood that that random curve explains the data points collectively? So that's a statistical question or a Bayesian question that you can ask, independent of any algorithm, of any Markov chain. So what we do then is we plug in this algorithm, this Markov chain Monte Carlo algorithm, and use it to repeatedly query that, get the answer to that question, calculate the likelihood that a particular starting model is going to explain that. And the Monte Carlo process, along with this thing called the Metropolis Hastings algorithm, basically said it's a clever machine learning piece that says, oh, look at this. if I randomly perturb this, the likelihood that I'm explaining the data, it's getting better. And so I'll keep going in that direction, and I'll keep doing that. And eventually it basically concludes, wow, now my random variations are not getting me anywhere. And now this natural random variation is showing me that. So Tira, hopefully that answered it. It's basically the application of a well-known machine learning thing, Markov chain Monte Carlo, and you're simply applying it to the likelihood that some decline curve actually explains the noisy production records that you see for a particular well.
Okay, and then we have a question from Sheldon. What is your point in your Monte Carlo simulation for DCA instead of running multi-feature forecasts?
Yeah, Guthrie, I don't know if you can. I would ask a little bit about multi-featured forecasts. I'm not really familiar with the term.
Yeah, I must
John,
confess, I multi-featured. What parameters go into a multi-featured forecast?
I think he might be referring to a multivariable.
Yeah.
Yeah.
So a multivariate analysis. So that's fine. That's a good theory, Thierry. If that's the question, then the difference is that with a multivariate analysis, like a regression, let's say, what happens is that there's some sort of least squares calculation that happens, and the noisy records are reduced down into a calculation that says whatever gives me the least amount of variance, right, from a least square standpoint between a model and the data is good. The big difference and the key feature here is that a multivariate analysis will give you one curve. It gives you one decline curve. Markov chain Monte Carlo will give you statistically a whole family of decline curves, as many as you can afford to calculate. And all those decline curves are going to be different. All of them will equally explain the data well if it's post burn-in. And so there's the big difference is in one case with a multivariate analysis, you get one answer. With a Markov chain Monte Carlo, you get a family of answers that give you insight into the risk and the model risk that's associated with your modeling project.
And you will be able to kind of output the uncertainty around each of these, let's say, models that you get from the Markov chain analysis, right?
Yeah, absolutely.
Yeah.
Yeah, great.
Okay, so hopefully that answers your question, Chip. Okay, so yeah, we got a follow up from him. The point is you can run Monte Carlo for each variable.
Absolutely. Yep. Absolutely. And the Monte Carlo is being done for each variable, but they're happening in unison. So the variables are being perturbed in unison. So you're moving around in 3D space, actually, in ARP space, right? As all of the Markov or the ARPS model parameters are being varied at the same time. But yeah, that's exactly right, Chip.
And are you able to, let's say, constrain or establish constraints around these variables when you perturb them in Markov chain? Or I guess, yeah.
Yeah, it's a good question, Atir. The one of the things that we've noted over the years, looking at decline curve fitting, is that there are certain parameters, and specifically either you can describe it as the time to exponential decline, how long is the hyperbolic phase of the decline curve, or equivalently you can define it with what the final exponential decline rate is. Those two parameters are interchangeable. It's very poorly defined. And if you and I, if we maybe a subject of another podcast, we could go through and look, and you'll see the convergence for the IP and the effective initial decline, the B parameter. They converge quickly, and they converge to a very tight range of values. That fourth parameter is our problem child, and there are techniques. To your question, Atir, there are techniques that are being used that we've used that will guide it. You can basically control it and say, all right, well, I know systematically in this field that the final decline rate is going to be 6%. When it gets to exponential, maybe that's a very uniform, pretty good guess. We can simply stop the Markov chain Monte Carlo from trying to determine that parameter and fix it.
And then is this doable from let's say the Spotfire implementation that you showed, or you need to do it, let's say, on the computation engine side?
On both. And what will happen is, in some cases, the like a previous incarnation of this algorithm, we had it so that somebody could set that algorithm or set the final decline rate, and then let the algorithm determine what's better. It may look and say, I get a better answer than you do with this, or I got lost, I never converged on this parameter, I'm going to use what you gave me, that sort of thing. So you can make it a hybrid if you'd like.
Okay. Well, thank you so much. This was very informative. I'm sure that we will get more questions when people come and then watch the on-demand session. So just a reminder, all of our Dr. Spotfire sessions are recorded, and then you can find them on our YouTube channel or by visiting spotfire.com, and then you go to the community. You will find all the details for our previous sessions. You can always, if you have any ideas, you can always visit our ideas portal, ideas.spotfire.com, to submit your idea or maybe vote for an existing idea over there, even if you have an idea for one of the sessions. And as we said, we have all the sessions are recorded. Also, our next session will be on the administration side, and specifically for the about the application profiler. And then feel free to reach out to us, doctor@spotfire.com, and then send us your suggestions or ideas if you have for data functions, demos, Dr. Spotfire session. And then with that, thank you so much, Steve and John. It was a really good session today. I enjoyed all the usage of the different Spotfire features. And then hopefully we'll have another session in the future with you. Thank you so much.
Thank you, Matir.
Thanks, everyone.
Thank you. Bye.